Hey, 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 we have another rational function here, and yes, more work, more steps. But this should be simpler than the last two. Alright, so our function here is x squared minus 2x minus 2 over x squared minus x minus 2. Now if we were to fact that out, you get x minus 2 times x minus 1 over x minus 2 times x plus 1. So we have a common factor. Those divide itself out into 1, and you're left with x minus 1 over x plus 1. So using this function, again, let's use the original. We're going to use that when we're doing the horizontal asymptote. So look at this one. The highest is the square on the numerator and the denominator. So they're the same degree. So that means top degree is the same as bottom degree. So in this case, all we're doing is just focus on these right here. So basically, it's 1x squared over 1x squared. Now since they're the same variable, same exponents, we can drop them or divide them, and we're left with 1 over 1. So again, we're just only going to focus on the coefficients, just the numbers. So 1 divided by 1 is just 1. If this was like 1 over 5, then this would have been 1/5. So you just simply divide the coefficient. That's all you're doing. So our horizontal asymptote is y equal 1. That's it. And I'm going to box that up, saying that this is going to be one of the important information we need for graphing. Alright. Now, using this function, after it was factored and then we took away the common factors, we have 1 factor in the denominator, so that means we're going to have 1 vertical asymptote. So, zoom in for a bit. We're going to do x plus 1 equal to 0. Solve for it. X equals -1. So therefore, we have a vertical asymptote at x equal -1. And of course, I'm going to box this up. Okay, now we have horizontal asymptote, we have vertical asymptote. Now, there's something we need to remember, our common factor. Since we have a common factor, that means we have a hole in the graph. So all we have to do is just find the coordinate of that hole. So what we're going to do is we're going to set the common factor, in this case x minus 2 equal to 0, just like vertical asymptote. So x minus 2 equal to 0. Solve for it. So we have x equals positive 2. Now what we're going to do is we're going to use this 2 in order to find the coordinate point. We're not going to use the original. We're not going to use the factor function. We're going to use the simplified function, x minus 1 over x plus 1. So we're just going to plug in 2 into the simplified function. So 2 minus 1 over 2 plus 1. Simplifying that, we're going to get 1 over 3. And the decimal value is 0.333. But we're going to do one decimal when it comes to graphing. So we have a hole on the graph at, here's our x value, 2, and then here's our y value, 0.3. So, in this example, we have horizontal asymptote, vertical asymptote, and a hole. Alright, now just like the last two examples, we're going to find the x-intercept and the y-intercept. So, now again, just to simplify, we're going to use a simplified function. Now for the x-intercept, we're always going to use the factor from the numerator. So x minus 1. So we're going to do x minus 1 set it equal to 0 plus 1 plus 1 x equals 1, so therefore our x-intercept is 1 comma 0. So again, 1 comma 0. So I'm going to write our x-intercept right here, x-intercept (1, 0). And then I'm gonna box this. That's gonna be one of the important coordinate points when it comes to graphing. And now let's do the y-intercept. So all we're doing is just plug in the y-intercept either in the original function or the factor function. Alright, so the original function was x squared minus 3x minus 2 over x squared minus x minus 2. So just plug in the 0. So 0 squared minus 3 times 0 minus 2. And then 0 squared again in the denominator minus 0 minus 2. So 0 squared is 0. Then minus 3 times 0 is just minus 0 and then minus 2. 0 squared in the denominator is just 0 minus 0 minus 2. So when we simplify, it's going to be negative 2 over negative 2. And then we're going to simplify that positive 1. So our y-intercept is going to be 0, because that's what we're plugging for x, comma 1. So our y-intercept is 0, comma 1. And I'm going to write that here. Y-intercept (0, 1). Alright, so we got x-intercept, y-intercept, horizontal asymptote, vertical asymptote, and a hole. Now, next is we just need some more coordinate points. So lucky for us, we have one vertical asymptote. So that means we just need 2 points left of the vertical asymptote and 2 points right of the vertical asymptote. So we do our xy table. Now again, we have 2 points, and then our vertical asymptote is at -1. So at -1, the left of -1, we can use -2 and -3. So -3 and -2. I'm not going to put a -1 because that's the asymptote. Now on the right of -1, we can either use 0 and, well, let's think about this. We don't have to use 0 because the y-intercept is using 0, so can't use that. We can't use 1 because there's a corner point right there. And we can't use 2 because that's their hole right there. So on the right side of -1, the only thing we could use is 3 and 4. So let me fill in the x values. 0, that's being used by the x-intercept. No, sorry, y-intercept. And then 1, that is being used by the x-intercept. 2 is the hole. So what we're going to do is use 3 and 4. So that's the x values we're going to use. But let me rewrite this. So there's a better view. So -3, -2. Again, won't use -1. Now, right side, we can't use 0 because we already have a point. Can't use 1. Can't use 2, but we can use 3 and 4. Alright. So let's fill in the values that we already know. So at 2, it's 0.3. At 1, it's 0. At 0, it's 1. Alright. So just 4 points we're going to plug in. So we can use the original, or the factor function, or maybe we could use the simplified function. So first one is -3. Let me see. Alright. So again, you can use the original function, the factor function, or the simplified function when you plug in these x values right here. -3, -2, 3, and 4. So first one is -3. Alright, let me write out the simplified function since it's less work. So x minus 1 over x plus 1. So we're testing out x equals -3, and then we're just going to plug in -3. So -3 minus 1 on the top, -3 plus 1 in the denominator. So on the top it's going to be -4 over -3 plus 1, that's -2. -4 divided by -2 is just a positive 2. So at -3, it's 2. So again, we can use a simplified function because it's less work, faster. Alright, so next one is x equals -2. We're going to plug that in. So -2 minus 1 on the numerator, and then -2 plus 1 in the denominator. -2 minus 1, -3. -2 plus 1, -1. -3 divided by -1, positive 3. Alright, so our coordinate point for x equals negative 2 is negative 2, positive 3. A lot faster than the last two examples. Alright, next one is we're going to test out x equals positive 3. Again, just using a simplified function. 3 minus 1 over 3 plus 1. On the numerator, 3 minus 1 is 2. 3 plus 1 in the denominator is 4. Simplify that, that's 1/2. Simplify that to decimal, 0.5. So, at x equals 3, our coordinate is 3, comma, 0.5. Alright, our last one is x equals 4. So, we're going to be in the numerator, 4 minus 1 over 4 plus 1. So on the numerator, 4 minus 1 is 3. Denominator, 4 plus 1 is 5. And then we can use long division check, but this is fairly simple. 3/5, 3 out of 5, that's 60%. Or in decimal value, 0.6. So at our coordinate for x equals 4 is 4, comma, 0.6. Way a lot easier than the last two example. Alright, so let's fill in our table, xy table. So at negative 3, it's 2. And then negative 2, it's 3. And then at 3, it's 0.5. And then at 4, it's 0.6. Alright. We got enough information to start graphing. Alright. Alright, zoomed out for a bit so y'all can see. Alright, so our center is right here, 0, 0. So this is going to be the y-axis. And then this is going to be our x-axis. Alright. Now, we have a vertical asymptote at x equals negative 1. So, if I zoom in for a clearer image, so that's 0, and then here's negative 1. So that's our vertical asymptote. So just a dotted line for vertical asymptote. And then we have a horizontal asymptote at y equals 1. So on the y-axis, here's the origin and here's the y-axis. So at y equals 1, 1 right there, that's the horizontal asymptote, so horizontal line. So okay, there we go. Alright, here's the vertical asymptote, here's the horizontal asymptote, and then here's the origin with the x-axis, and then the y-axis. Alright. Now we can mark our x-intercept, which is 1, 0. So starting from the origin, x-intercept is 1, 0. So 1, 0 is right there. Let's use a different color. Don't want to get mixed up with the origin, so 1, 0. And then our y-intercept is 0, 1, which is right here. So 0, 1. That's the horizontal asymptote. So, that's funny. Don't want to mess with that because it's touching the horizontal asymptote. So I'm not going to mess with that. Alright. We're going to start graphing the points. So negative 3, 2. So I'm going to use this color. Negative 3, 2. So if we were to zoom in, clear picture. So negative 3. So 0, negative 1, negative 2, negative 3. And add 2. So 1, 2. Done. Next one is negative 2, 3. So negative 1, negative 2 for the x, and then negative 1, positive 1, positive 2, positive 3. There we go. Alright, so we finished with that point. Now, right here, we have the x-intercept, and then we're also going to have a hole at 2, 0.3. So I'm not going to draw that yet. Now, we're going to do 3, 0.5. So here's the origin, 1, 2, 3, and then we're going to do 0.5 right there. And then the next one is 4, 0.6. So on the right side, it's going to be a bit above the previous point, so 0.6 right here. Alright. Now remember, we have a hole at 2, 0.3. Excuse me. So, what's going to happen at 1, 2, and at 0.3 is right here. But I'm not going to mark a dot. I'm going to do a circle because it's going to be a hole. A circle. Alright. So now, we're going to connect the dots. So here, if we connect these two, now we see that this one is close to the vertical asymptote, so I'm going to use it as my guide and then just graph along the vertical asymptote. Same thing with my horizontal asymptote. I'm going to use it as my guide, and this won't cross the horizontal asymptote. Same thing over here. Connect all the dots with the hole. So again, I'm not going to cross the horizontal asymptote. And then over here, just like my x-intercept and vertical asymptote, I'm just going to use my vertical asymptote as my guide and then just graph along to it. So, here's our graph. Now again, if we look closely, there's a hole at x equals 2. So that's what it's going to look like when you have a common factor. Vertical asymptote, horizontal asymptote. As you can see, our graph is not crossing. Now, you can check this on Desmos, but it won't show you the hole in the graph because it's not programmed to do so. So if you activate the option, it will show it to you. Or if you set in the function, it will show you the hole. But, again, on the graphing calculators and Desmos, it won't show you the function where it has a hole in it. So you gotta be very careful. When you do a physical graph, you have to show it. The calculators, Desmos won't show it to you. So it will give you a false representation of it. So here again, this is the graph, and then when you type it into decimal, the original function, it will be just like this, but you will see it without the vertical and horizontal asymptotes.